Did everyone get that? Yeah. So this really kind of indicates how people have regarded bogs and wetlands for really quite a long time now. So if you think about how we use these words in language, so we've got all sorts of sayings like getting bogged down or mired in controversy or getting swamped by the detail. So pretty much they've been regarded as dangerous, unproductive places for people. So for a long time now, people in the UK have tried to drain wetlands and use them more productively. This really started on a reasonable size scale with the Romans, not necessarily on Dartmoor, but elsewhere in the UK, and has continued ever since. Now, these two maps show you what's happened over the years. I apologise for the quality, but I had to lift this off the internet. So the map on the left shows the historical maximum extent of wetlands in England. So all those purple areas in the outline of England on the left are where wetlands used to be in the past. And the map on the right shows where wetlands had retracted to by 2008. So you can see that an absolutely huge area of wetland has been drained for more productive agriculture, for urban development, for various things like that. So to get specific about Dartmoor, I'm going to be talking about two types of wetland on Dartmoor. This is a picture of Blanket Bog. Now, bog, if you're talking about a scientific term, a bog is a wetland that is fed exclusively by rain, not by overland flows of water and not by rivers. It's what falls out of the sky. And counterintuitively, the place you find Blanket Bog is at the top of hills. So the plateau, some of the plateaus on Dartmoor are covered with this boggy wetland. And the other type of wetland I'm going to be talking about is valley mires, which are very similar to bogs, but the big difference is they get some of their water from surrounding hills. And what that means in practice is that the water in the soil has a slightly higher mineral content and slightly less acidity. And that changes the sort of plants and wildlife that you find in them subtly. Now, the thing that these two habitats have in common is peat soil. So peat soil is a special kind of soil which forms in very wet places. The waterlogged, acidic and low oxygen content conditions stop the dead plant material from fully decomposing. So that over the years, this dead material builds up layer on layer to create this deep peat soil. Now, some of the blanket bogs in Dartmoor have been accumulating peat for 10,000 years now, and in places the peat can be up to 6 meters deep. So these places, a healthy bog is always laying down extra peat. Now, ecologists talk about some species as being ecosystem engineers. The one that most people have probably heard about is beavers, and these are considered ecosystem engineers because they can change the structure of a river and change how it works as a habitat, and this has a knock-on effect for all the other species around them. Now, in our bogs and mires, our ecosystem engineer is sphagnum moss. Now, this picture You have to be quite a good botanist to tell the difference between all the various sphagnum species. I think this one, since I'm not a particularly great ecologist, we're going to call this one Sphagnum subnitans, or possibly Sphagnum capillifolium. But you'd need a botanical eyeglass and a little sample to try and sort of iron out which one it was. But they do come in quite attractive colours, these sphagnum mosses. So you get one or two of these deep rust red coloured ones, and then you get various ones that are much brighter virulent green and ranging through to sort of light green, khaki dun coloured ones. Now, the reason this is an ecosystem engineer is that it stores water. So if you got a handful of this moss and pulled it out of the ground and gave it a good squeeze, water would pour out. The other thing it does is there's a chemical process in its roots which lowers the pH of the water around it. So it makes the water and the soil around it more acidic. Now, because these systems are rain-fed, they're mildly acidic anyway, but sphagnum moss increases the acidity, and this is one of the things that's vital for peat formation. So peat is not just made up of sphagnum moss, it is made up of lots of different species of vegetation. But you don't often find places where peat forms without sphagnum moss being present. So it really is a key species. This picture just shows you how the moss, the peat formation works. So you've got a whole depth of peat, which is effectively dead vegetation but unrotted. Then you've got an area which is laying down peat, and that's where the sphagnum roots are and where sphagnum is dying off, and then a living layer at the top. In the early 2010s, Southwest Water and Dartmoor National Park Authority commissioned the University of Exeter to try and discover where all the peat soils were on Dartmoor. And through various techniques, they came up with this map for us. So the blue outline is the Dartmoor National Park boundary. The green colour is peat soils of greater than 40 centimetres depth, and the yellow areas are peat soils of less than 40 centimetres. So at some point in the history of Dartmoor, all of these places would have been bog habitats to one extent or another. And it's a decent proportion of Dartmoor National Park. That's about 315 square kilometres in total, which is peat soils. Now, these peat wetlands are actually a quite harsh environment. They're waterlogged, acidic. Within the water, there's a lack of oxygen. And as a result, they're not particularly wildlife-rich habitats. So if you went to an ancient woodland or one of Dartmoor's nice hay meadows, you'd find far more species per square metre than you would in one of our intact bogs. However, what this means is that a lot of the species that you find in these wetlands are highly specialised. They've adapted themselves for these particularly harsh conditions, and that means they are naturally scarce species. Just to give you a little run through of some of the ones that you might find on bogs, this is a plant called sundew. Now, one of the problems for plants in these peat bogs is there's a relative lack of nutrients available in the soil. And this species has adapted to that situation by becoming carnivorous. So these red tinted leaves with the spines on, the sticky droplets on the end, these sticky droplets are sweet and they attract insects in. And the insect lands to partake of the nice sticky sweet substance, but gets stuck in it. And then when the plant detects that there's an insect struggling stuck on its leaf, the leaf will gradually fold over and enclose the insect, and the insect will be digested. And it's just a way of these plants supplementing their diet. Another plant that's very characteristic of bogs and mayers is bog cotton grass. Now, you'll see these, it's like a grass stalk, but on the end of the grass stalk, when it forms a seed, it's like a little ball of cotton wool on the top. And you can get these quite spectacular displays in late spring and early summer as they come into flower. This is another bog specialist. This one's called bog asphodel. There's not too many sort of colourful flowering plants that you find in bogs, but this one can be really pretty and quite spectacular. As far as animals are concerned, again, these are very specialist species. So this one is a particular species of ground beetle. Not even got a common name from what I can gather, but its Latin name is Agonum ericetti. And this ground beetle is restricted to habitats that are totally rain-fed. And this is one that we've got on some of Dartmoor's intact bogs. Similarly, this dragonfly, the black darter, that will lay its eggs in bog pools, and its nymph stage will live in those bog pools and feed off other insects. And that is another blanket bog specialist. In terms of birds, you'll find a lot of wading birds in these boggy wetlands. They're adapted for it, long legs for wading and the long beak for hurtling about in bog pools and probing the peat for invertebrates, which is what they feed on. This one is trying to confuse us by standing by some fairly bog standard grassland with daisies in, but they do breed on Dartmoor. That's where on the blanket bogs, not on grassland like this. And Dartmoor is their most southerly breeding habitat in the world. They tend to be more of a species of further north towards the Arctic tundra. The peat is also important from an archaeological point of view. This is a picture of the White Horse Hill Kist, which was discovered a few years ago on White Horse Hill, just south of Oakhampton. And this would have been, there is some stone archaeology which actually predates the formation of peat. So there will be things like stone rows and what have you that have actually been overtaken by peat growth and are buried in it now. But this was during peat formation, and a kist is a kind of container built out of stone slabs used to put cremation urns and grave goods in. Now, the peat itself is also important from an archaeological point of view because it actually contains a record of past conditions and past land use. So archaeologists can take a core of this peat, which is like a column of peat, and that's like a historical record going back thousands of years, and they can examine the peat and discover what pollen is contained in the peat, and they can even also find little microbes like amoeba. And this will tell them roughly what the habitats were like in the vicinity of that bog going back many thousands of years. So the peat itself is an archaeological resource. Now, I think my brief for this talk was to be inspirational. But I'm afraid there always comes a point in these ecological talks where we have to talk about the current condition. And the truth is that Dartmoor's peatlands are not a pristine wilderness. Unlike other wetlands, they've not really been well regarded in the past. And the main question for humans has been how to exploit them. So you look at a picture like this, and a lot of us would want to describe that as a wilderness or an area where there's lots of nature. In fact, most of the peatland areas on Dartmoor have been variously dug up, overgrazed, set on fire, bombed, and been driven over by tanks in the past. And as a result, they are very far from a natural wilderness. So, if in the past people considered bogs to be wet, unpleasant, unused, and empty, what does that make them perfect for? Well, the answer was they're perfect for military training. So, since 1800, parts of Dartmoor have been used for this. And that really reached a peak during the Second World War. So, as well as artillery practice within the moor, they were bombed from the air. So aeroplanes returning back from bombing raids, if they still had payload, rather than trying to land with the payload, which is extremely dangerous, they would drop the bombs somewhere where there weren't very many people, and Dartmoor was very convenient for that. It's also been shelled from the sea. So the Navy would moor warships in Plymouth Sound and fire onto Dartmoor for target practice. An even longer history has been peat extraction. There's evidence of peat extraction on Dartmoor. I'm sorry, I could only find an Exmoor picture to illustrate this, but there's been peat extraction on Dartmoor since the medieval times. And by and large, this has been small scale and for domestic use. But that still has an impact. These pictures show Riders Hill on the South Moor, which is the area in the top left of the picture. On the left, there's an aerial photo. On the right is a photo using what's called LiDAR, which is a kind of laser system which measures land height very precisely. And you can see all these oblong shapes going down the hill from the peak of Riders Hill. These are domestic peat cuttings. And they're not massively visible on the ground, but what they do is take water off the bog quicker than it would naturally go. In other places, peat extraction was on a much more intensive scale. So in the late 19th and early 20th century, it started in really industrially. So this, the photo on the left is Rattlebrook Peat Works, which was on the northwest of the moor. And the aerial photo on the right shows the area where peat was extracted. And each one of those little lines running down the hill towards the peat works is some sort of drain or peat cutting. So all of these were cut by the peat extractors to take water off the site and dry the peat out sufficiently to make it extractable. And that factory was producing a substance called naphtha, which I believe was used to run lamps from pre-electricity. Something else that happened in the 19th century, this chap called Philpott decided to clear peat passes across the moor for the use of the hunt and of people droving cattle as well. So in various places on the moor, you'll see these cuttings through the peat, which help people cross, but also carry water off the bog. Agricultural use of the peatlands has always happened to one extent or another. Throughout history, there's been various ups and downs with the amount of stock that's been grazed on there. But really, there was a very heavy peak in the 60s, 70s, and 80s as a result of agricultural subsidies. So farmers were subsidised to keep animals, and of course they maximised their income, as you would expect them to. And the moor was very, very heavily grazed, which also has a drying effect on it. And Also connected with that, the moor has often been burnt in the past to take off the dead thatch of vegetation off the top and get a fresh new growth for grazing the following year. Now, the effect of this is it tends to damage the top layer of peat and tends to encourage the dominance of grasses over bog species. So another thing that has a drying effect on the peatlands. I just want to show you what the net result of all those things that humans have done to the wetlands over the years. So in places on Dartmoor, you'll find severely damaged areas of peat. So there's very big, what we call pans of bare and barely vegetated peat, which are very dry, particularly in summer. And this is a picture from Hanging Stone Hill, just south of Oakhampton. In places, as the peat dries, water flows off it a lot more quickly and the peat becomes rather crumbly. And the net result of that is these massive gullies form within the peat. And in winter storms, these gullies will carry a massive amount of water, and they have a serious drying effect on the peat, the areas of peat and the habitat around them. You tend to get these things called hags forming, which are almost like small cliffs of bare peat. And again, this causes the peat to erode. And it's not just on the surface that the peat erodes. If you dig down in the peat, particularly under some of those small foot drains that I was showing you earlier in the peat extraction areas, you often find something that's formed underneath called a peat pipe. And this is caused by the movement of water eroding the peat underground. And when those peat pipes get big, they turn into these sinkholes. And in a couple of places, this is a sinkhole from one of our restoration sites, Flattor Pan. You could quite comfortably fit 4 or 5 people in there. I'm not proposing you should try, but you could if you wanted. And as a result of this, the overwhelming majority of Dartmoor peatlands now look like this. They're not functioning bogs anymore, and they are a monoculture of a particular species called purple moorgrass. Now, at the same time as University of Exeter were mapping the extent of our peatland, they had a look at what they thought was the still intact areas of bog. And this map shows those. So the small areas of blue, these are the areas where there is still roughly intact bog. And it's a tiny proportion of the overall peatland. Their estimate is that there's only about 1% of the total is still intact bog. Now, you could ask, does this matter? Because Dartmoor's still an enormously popular place with visitors. The landscape's still beautiful. What's the problem? Things change. Well, there are a number of reasons why it is a problem. National parks are the flagship for this country's nature as well as its landscape. And we are losing bog species on Dartmoor. So this bird is called a golden plover, which nested on Dartmoor until maybe 10 or so years ago. I think the last recorded pair were. And again, these are a species of bog habitats. They are wading birds, despite the slightly shorter beak, and they're gone now. We still get wintering plover, but not as breeders. Now, this is a curlew, another wading bird. These are more a Valley Maya species rather than bog species. And on Dartmoor now, we're down to our last few nesting pairs. Again, you may see wintering curlews up here, but as a breeding species, they are right on the brink of being lost from Dartmoor. And these were species that would once have been abundant. Now, realistically, some people aren't that bothered about wildlife. So is there any other reason why we should care? Well, about 45% of the water supply in Devon falls as rain on Dartmoor, and it's where a lot of our main rivers rise. And one of the impacts of the peat eroding is that the quality of the water coming off the bogs and the peatland and off Dartmoor is not as good as it used to be. So eroding peat, as well as getting peat fragments in the water, there's also something called dissolved organic carbon. So the water actually absorbs some of the carbon, and it turns this sort of tea-coloured liquid, which can be a real problem for the water companies, which is why South West Water is so heavily involved in restoring peatland. It also has implications for floods and droughts. A properly functioning bog soaks up rain in heavy rainfall events and releases it slowly in drought conditions. Now, damaged bogs don't do that anymore. I just want to say I've been going for about half an hour now, and there's probably another 10 minutes. I hope that's not a problem for anyone, but I apologise. I'm going to overrun a little bit. Now, another thing that we're concerned about, in the UK, there is more carbon stored in peat soils than there is in woodland. It is a massive carbon sink. Now, we know that the damaged peatlands release carbon into the atmosphere as carbon dioxide, whereas the small areas that are still intact bog are still accumulating carbon out of the atmosphere. Now, if the bogs carry on degrading, they will carry on contributing to climate change. And that is obviously a major concern. Now, this just shows you what happens to peat when it dries out. So a decent proportion of the volume of peat is water. So when it dries, it shrinks. But another reason it shrinks is because the processes that break down vegetation restart when it dries out. So the vegetation element of it is broken down by microbes and released as carbon dioxide or methane into the atmosphere. And that leaves this sort of gritty, mineralized element of the peat left, which is highly damaged, and water, it doesn't hold water anymore, and water goes off it very quickly. It's also a real problem from an archaeological point of view, because all of that data that's stored in the peat in terms of pollen and amoeba and what have you, all that history of past land use is lost when the peat dries out. But on a more optimistic note, we are trying to do something about this. So Dartmoor National Park Authority and South West Water are leading a partnership project to try and restore a lot of Dartmoor's peatlands. And well, we're about 2 years into a 3-year project to restore about 300 hectares of peatland. So this map shows the 5 sites we're working on. One of them actually falls right in the O of Dartmoor Forest there, which kind of disguises it a little bit. But yeah, it is definitely still there. So these are the sort of things that we're doing to try and restore the peat. This is an area on Amicum, the industrial peat extraction site that I showed you pictures of earlier. And you can see the lines coming down the hill towards you in the bigger picture. These are small foot drains in the edges of peat cuttings, which were used to take water off before peat extraction. And the little photo on the bottom right shows what they look like close up. So what we do is we get excavators in and we create these little peat dams within those features. Now, when we're doing this, we scrape the vegetation off the top and then we take a scoop out of the peat using the digger bucket, turn it over and tamp it back down really hard with the digger bucket. And the purpose of this is to block up any peat pipes that have formed underground and make sure we've got a good watertight seal in that little dam. And it's quite an undertaking. I think on Amicum we've blocked about 35 kilometres of ditch, and we've used I can't remember, in the region of 10 or 15,000 of these dams in order to do it. And then when you've got these horrible big gullies that have formed, this one's well over head height, it's really hard to know how to block those up. So one approach we've used with the biggest gullies is to reprofile them. So we strip the vegetation with an excavator off the top, create a much gentler slope with the peat, and bring the base of the gully up slightly, and then put the vegetation back on. So that it's a much less dramatic feature. So this next picture is the same gully immediately after restoration has taken place. Now, the equipment we're using is incredibly low ground pressure. So they're 8-9 ton diggers, but because of the width of the tracks that they're on, they're less ground pressure than a human walking over the bog. So this is why we can go in and do the work without creating a horrible, horrible mess or sinking in the peat. Now, with the slightly smaller gullies like this one, they're really too big and carry too much water to block up with blocks that are just made out of peat. Those will get washed away. So what we do, we use timber to build a timber dam and then cover that over with peat and vegetation to end up with something like this. So we've then got a feature that's holding far more water. And these pools will gradually fill up with sphagnum moss over the years. Just a very quick one to show the process of building one of these dams. So we strip the vegetation off. This is a very small dam. We built some that are 3 or 4 posts wide, but we get the digger bucket to push the posts in, put planks on to create the wooden dam, cover the dam over with peat, and then pop the vegetation back on top. And immediately after we've finished, that's what it looks like. So in places, you would really struggle to tell we've been there after a couple of months and the vegetation springing back up. Now, some of the hags are very serious, and this is one on our flat tall pan restoration site, which is well over head height. And again, we try and reprofile these. So this is what it looked like after we've done the reprofiling and the restoration. And the peat pans, the big areas of bare peat or barely vegetated peat, we use the islands of peat in the middle to create dams in strategic places to try and re-wet these. So this is one on our Hanging Stone Hill restoration. This is a before photo, and this is what it looked like after we'd done the restoration. Filling up with water, and this will get colonised with sphagnum and start forming into nice bog habitat again. One of the really gratifying things about working on this, most of the conservation projects I've worked on in the past, you have to resign yourself to the fact that the impacts will be felt over decades. And it's really different working in these peatlands. So this is a timber dam that we built in a gully, which filled up in an afternoon. So that's 2-3 hours time after we put the last plank on. That's what it looked like. And it filled up before we had chance to put the peat back in and cover it over with vegetation. You'll be pleased to know we did put the peat back in and cover it over with vegetation, but it's just a nice illustration of how quickly we can have an impact. Now, back in 2009 to 2014, Southwest Water and Dartmoor National Park had a little pilot project to prove that it was possible to do this on Dartmoor. And we restored a few small areas, and University of Exeter monitored what happened after the restoration. And what they found was that in our restoration areas, we raised the water table by an average of 9 centimetres and up to 14 centimetres in the most damaged areas. So we've properly re-wetted some of these areas, and we are storing a lot of water up there. University of Plymouth monitored vegetation, and they've seen an increase in bog plants on our restored sites. The RSPB helped us out by doing bird surveys, and they showed that dunlin numbers increased on our restoration sites. University of Exeter, looking at how the bogs function in terms of how they handle water, they found that in the erosion gullies, we slowed the rate of water by 66% for equivalent daily rainfall events. So the bogs are much less flashy, they're holding water on for longer, and this will reduce flood risks downstream. Water quality's improved, the dissolved organic carbon reduced by 70% in water flowing off our restored bogs. The one thing that we haven't shown an improvement yet is in the greenhouse gas emissions. Now, what happens when you restore one of these bogs is that initially there is an emission of methane. Now, methane is quite a serious greenhouse gas. It's worse than carbon dioxide, but it doesn't last as long in the atmosphere. It breaks down quite quickly. So what evidence from other peatlands suggests that it takes somewhere between 8 and 12 years before that methane effect is knocked out, and you start coming into credit on the carbon emissions as the carbon dioxide emissions come right down. So we're restoring these for the future, and this will have an impact on making sure that our peatlands aren't emitting carbon into the atmosphere. A couple of pictures to prove how quick the impact is. RSPB took this, one of their, I think he was doing it as a volunteer or as a contractor, Chris Townsend, took this picture of a juvenile dunlin feeding in one of our newly created bog pools. He took this picture with a camera phone through a pair of binoculars, amazingly. And another RSPB contact, Mike Sampson, he had a trail camera out there, one of these movement triggered cameras, and he caught dunlin landing in the new pools. One of the drawbacks about working in peatland conservation is because of the ground nesting birds, we have to do most of our work in winter. And this is the downside. These are the conditions that I normally spend my time working in. And I just thought I'd quite like to end by trying to elicit a little bit of sympathy from people. So I just want to play you this video of a typical day doing peatland restoration on Flat Tor Pan. Right, I'm going to leave it there, you'll be pleased to know. I just want to say, if I've not put you off bogs for good, there's a couple of places you might like to go to explore things more. So this page here, the devonwildlifetrust.org Magnificent Myers project, there are some links on there to PDFs which suggest walking routes where you can check out some, I think they're mainly Valley Myers rather than bogs. I'm also aware that one of our Dartmoor guides, Jerry, often does bog-themed walks, and she will get you into the blanket bogs, because as you can imagine, they tend to be the more isolated and lonelier end of the Dartmoor spectrum. So that's Jerry's email if you're interested in trying a guided walk to one of our bogs.